In this video, we present a brief demonstration of our work on 3D multiview graph data visualization. The goal is to visualize a dataset or a graph in 3D, such that if you look at it under different angles, you see different interpretation of the dataset. For example, we could have a 3D dataset such that if you project it on XY, XZ, and YZ planes, we see a different perspective of it. We propose a mathematical formulation of this problem in two different settings. The first setting considers the case when the projections are given and the algorithm needs to embed the dataset in 3D such that on given projections we recover the desired interpretations. And second, we propose an algorithm which embeds the dataset in 3D and finds the best projections under which the best possible interpretations are achieved. We created an interactive tool where we demonstrate several datasets under the described setting. The first example contains a dataset that consists of digits 1, 2, and 3. The motivation behind this dataset is the famous 1, 2, 3 statue. So for the first example, we only consider two views and digits 1 and 2. And the goal is to place the points in 3D. So the first given projection, you get digit 1, and under the second one, you get digit 2. The problem gets harder when we have three views. For example, here we consider all the digits 1, 2, and 3. And if we rotate, we can see the digit 3, digit 2. But as we can see, the result for 1 is not great. This is due to the hardness of the problem. Some other examples include geometric shapes. Let's say we have circles, squares, and triangles. So for example, if we have only two views and we consider the circle and the square, we can see the results. So we have points in 3D such that if you look at it on, let's call it XZ projection, you get the circle, and if you keep rotating, you can find the square. The other example we call a grid path dataset, where we want to find an embedding of a graph in 3D such that if you look at it on XY plane, you see a grid, and if you look at it on XZ plane, you see a path. And this is the result of our algorithm.